Welcome to chapter 6. So we're starting on a new chapter, but this chapter is going to be critical for everything else that we're going to go on further, and it's going to relate to several things we've already done. So the thing about this is something called removing a common factor. So let's just go through some basic vocabulary. First off, what's a factor? Well, a factor is literally a number or algebraic expression that multiplies into a given term or polynomial. Okay, the biggest thing about there, it multiplies into, or in other words, I can easily divide it out. So the factors of 12 are all the numbers that I can multiply by something and they go into 12. And these include 12, because 12 times 1, 6, because 6 times 2, 4, because 4 times 3, and 3, 2, and 1, because I've already told the other they multiply by. Because all those numbers go evenly into 12, we call them factors. Well, the same idea is with a polynomial. You're asking what are smaller polynomials or numbers that I can pull out of an entire thing. So this is the opposite of all the multiplication we did at the end of chapter 5. So what is the greatest common factor? Well, a couple key terms here, greatest and common and factor. Well, greatest means it is the biggest factor among all the terms. So that's why it's common. So just to kind of understand this, let's look at some examples. So here are two terms, 10x squared and 15x. What is the greatest common factor? So I'm looking for the greatest thing they have in common. Well, let's start with just the numbers, 10 and 15. What do the numbers 10 and 15 have in common? Hopefully you're saying they both have 5. What about x squared and x? Well, they both have an x. And that is the greatest common factor, because I can't pull any number out of both 10 and 15 that is larger than 5. And I can't pull any more x's out since there's only x in the 15x. So that is the greatest common factor of those two. Let's try it again here. So I want you to pause the video and I want you to find the greatest common factor. All right, now that you've done that, hopefully you start with numbers. 12 and 8, the greatest common factor of those two numbers is 4. And y cubed and y squared. So 4y squared is my greatest common factor. So we've now done this for 2. Can we do it for 3? So pause the video and find the greatest common factor. All right, so first off, it gets trickier with 3. But still, let's focus on the numbers. I have 16, I have 24, and I have 32. Well, 16 doesn't go completely into 24, but 8 does go in all three of those numbers. And you can factor them and realize that that's the number that goes into them. What about the a's? Well, a squared is the smallest of all of those, and that's the one I'm gonna go with. So that is how we find a greatest common factor. Well, we now use it because we're gonna factor it out. So the way we factor it out is you better first find the greatest common factor. So on this example, 5x squared plus 20, I want you to first see that 5 goes into both the numbers. Okay, so that's my greatest common factor. Well, now I got to ask the question of each of the terms. So 5x squared, if I divide that by 5, so I factor 5 out, what's left over? Well, just x squared. If I divide 20, positive 20 by 5, I'm left with 4. So this is factoring that thing right there by the greatest common factor. So look, again, you look at each of the terms, and then you divide out the greatest common factor. So let's do another example. The greatest common factor. So I want you to pause the video and at least find the greatest common factor, and then try to divide it out, and then start the video again. Okay, so hopefully you looked at this and you said, okay, 4 and 3, nothing common. Only x in the first term, not in the second. But y, that's in both of them. Now if I take y out, my terms turn out to be 4x plus 3. That is all you have to do for greatest common factor. So notice it's pretty straightforward, not a ton of work, but this is the idea behind what we're doing. So again, I want you to practice this. I want you to pause the video and factor out the greatest common factor of 30x squared plus 18x. Okay, so hopefully you found the greatest common factor first, and that turns out to be 6 is the number and x is the variable. So 6x is my greatest common factor. And then we pull out that from 30x squared and we're left with just 5x. Now, when you pull 6x from 18x, well, the x's obviously go away, and you're left with just plus 3. Now, I want you to quickly ask yourself the question of, how could I check my answer? Could you multiply it back out, just like we did in the last chapter? If you multiply it out, shouldn't it go back to the original problem? So on any of these, you can always check by multiplying it back out. Now let's move on to some bigger fish. Let's find the greatest common factor when I have 3 terms. So first, find the greatest common factor and then factor it out. Go ahead and pause and do it. All right, so the greatest common factor of these 3 terms is 6x. Now, when I pull that out, so the first term, I'm going to take 24x to the 4th, and I'm going to divide that. So 24 divided by 6 is 4, and x to the 4th divided by x is x cubed. So I have 4x cubed. If you didn't get that right, go ahead and pause and try to do the same thing on the next two. Otherwise, let's keep going. The next one, I'm just left with 3x, because 18 divided by 6 is 3, and x squared divided by x is just x. But the last one, minus 6x divided by 6x. Well, that's going to be minus 1. So don't just drop it. It doesn't go away, because we're still left with a 1 of the factors that's being left behind. So this is the general idea behind all this. I want you to try this one. Now this is a multivariable one, so you have x's and y's, but again, look for the greatest common factor, look at the numbers, look at each variable, and then factor that out from each of the separate terms. Go ahead. All right, now as you did this, hopefully you realize that 9 is the number that goes into all 3, and x goes into all 3, but y does not, so all you have is 9x is my greatest common factor. Well, if you do that, then pull that from the first term, you're left with just x squared. The second term, we're left with minus 4y, and the third term is plus 3x. So this idea of how we're pulling out the greatest common factor, we're doing over and over trying to get this in, because this is going to be really important in the future sections. So here's another one, multivariable. I want you to pause the video and I want you to try this one. All right, so first off, 2 is the number that goes into all of them, because notice 2 is the smallest, so that's the max it can be. What about x's? Well, if you said x squared, what about y's? Well, there's a y in all of them, so we get a y. Now, ignore that. What we have here is we pull that out, we get 6x squared y squared. And then we subtract and we get minus 10xy. And the last term, again, when I divide that, it's going to leave just a 1 because it's still there. And so I have to account for it. But it's just going to be a little bit different. All right, this one, now we're changing it up a touch. So I want you to try this problem. Ask yourself, what is the greatest common factor of these two terms? Well, that's actually kind of tricky because what do they both have? Well, they both have an x plus 14. So that is actually my greatest common factor. And if I pull that out, what's left in the first term? Well, just x. What's left in the second term then? Plus 6. So we just factor this by pulling out the greatest common factor. Last example is still the same idea. So I want you to pull out the greatest common factor of this one. All right, so hopefully you did that. And first off, you should have recognized, again, the greatest common factor in this case is not just a number, it's an actual polynomial, 2y squared plus 7. And when you pull that out, you're just left with 3y for the first term, And again, you get a -1 because don't forget there is that 1, it just is not being shown for the other one. So this is how we get our greatest common factors, pulling them out. Now, this idea that I'm doing here is also going to lead into the very next section where we talk about how to factor polynomials in general besides just this. So please let me know if you have any questions. Otherwise, good luck.